All right, everyone, let's go ahead and get started. So today's webinar is Geoslam for the real estate market. I'd like to start out by just thanking everybody who's on the call for joining us. And also, if you're watching a recording of this, thank you for taking a look at the webinar and post. It's always my pleasure to present our products and talk to them, talk about them with people who are interested. So we're going to be talking about the real estate market and how Geoslam products and technology are able to impact different workflows and different applications in different areas of the real estate market. So before we get started here, I'm going to go ahead and introduce myself. My name is Brian Rosensteel. I'm a senior solutions architect with Geoslam based in the Western United States. There's my email in case you want to reach out to me about anything following this or just in general. Just to give you a little bit of background on myself, my background is in laser scanning, mobile mapping, reality capture technology, as well as scan to BIM and scan to CAD workflows and applications. I personally worked in the construction, architecture, engineering, and real estate development industries. Before I was a employee of Geoslam, I was actually a customer and end user of Geoslam products, and the company I was working for was using Geoslam's products for architecture, engineering, construction, and real estate development applications. So I do actually have some firsthand experience in this technology and in these applications. So I'm happy to be a resource to you if you have any additional questions or need to know anything else following this webinar. So just some basic webinar info. I kind of talked about a couple of these before we started, but a couple commonly asked questions. Just to address those, a recording is going to be sent to everybody who's attending these following up. If you have any questions throughout the presentation, please feel free to submit those into the Q&A panel on the right-hand side, and we will have a Q&A session at the end where I will address any of those questions. If any questions come up later on or you are watching a recording of this, please feel free to send any questions to info@geoslam.com and we'll address those. For more information on our company and on our products, please visit geoslam.com. And if you're interested in learning more or you're interested in a demo, please reach out for that. We have a global team, a network of dealers that support our products. We also have a mailing list that you can join. And we've also just recently announced that we are doing a demo in a box solution for customers or potential customers who are interested in getting their hands on the technology and want to use that to evaluate and ultimately purchase it. So more information is on our website about the demo in a box program, so check that out. All right, quick run through of the agenda for today's presentation. We're going to introduce Geoslam and then introduce our topic, Geoslam for real estate, and kind of give an overview of that. Then we'll get into our products. We'll do an overview of both the hardware and software of our products that pertain and are commonly used for real estate applications. Then we'll actually talk about some of those real estate applications, and I'll show some videos and some visual examples of what those look like and how they're being used within the real estate industry. Next, we'll talk about workflow. I have some screen capture videos that I'll talk through that show really kind of simply how to create two-dimensional plans and three-dimensional models using point cloud data and doing that through our products and then also into Autodesk products such as Revit and AutoCAD. Then we'll touch on a couple of user case studies. We'll talk about a couple of our customers who are doing work with our products in the real estate industry and how they're able to use those to service different aspects of the real estate market. And then we'll follow up and conclude with a Q&A session. So again, please enter any questions that you might have in the Q&A panel. You don't need to wait till the end. You can enter them as we go through, and then I'll address them at the end, and hopefully I'll have time to get to all of them. All right, so just a quick introduction of Geoslam in our company. My assumption is that most of you have had exposure to our products, whether you're actually a user or a prospective customer, or you're just here to gain some more information. We welcome you, but we'd like to just start with kind of a quick introduction of what we do. So Geoslam creates, manufactures, and sells three-dimensional mapping and laser scanning products, as well as software to support those products. And then ultimately, what we're able to create with our laser scanners is a three-dimensional point cloud, and that point cloud can be used for a variety of different applications, and we'll get in depth into that during this webinar. So one of the real powerful parts of our technology is with our SLAM algorithm and our mobile mapping solution. We are able to map unknown spaces in a very accurate and efficient way. And when we do that, we are not relying on any kind of external sensors. So we're not relying on a GPS to do that. We're not relying on any kind of external georeferencing targets or control points. However, we do integrate with all of these in order to place our point clouds on coordinate systems, and I'll touch on that just a little bit later. So the real use for these point clouds is they can be brought into any third-party software that consumes point clouds. We export to universal file formats such as E57 and LAZ, and then just about any software out there that exists that is able to consume and derive value from point clouds is able to work with data from our scanners. All right, so let's talk a little bit about Geoslam and how this technology applies to the real estate market. So we're able to add value to a lot of different aspects of the real estate industry. A lot of these applications that we're going to talk about also intersect with the architecture, engineering, and construction industries. We also are very active in several other industries because our technology is so versatile and easy to use. We're able to do applications within industries like mining, a variety of different surveying applications, industrial applications such as manufacturing, warehouses, material handling, things like that, utilities, infrastructure, transportation, forestry, geological surveys, and that's just to name a few. We find new applications for our technology every day, so it's really versatile and can be used for a variety of different things. So the real power of this technology is that we're able to quickly and accurately create a three-dimensional digital document of any space, any objects, really anything that you can see, you can capture with our scanners. And then we're able to create what many people refer to as a digital twin of an existing environment. And digital twin basically just refers to any kind of accurate representation, digital representation of a real world object or space or area. So we apply that to real estate market in a variety of different ways, and it can be used to help inform things like the actual real estate deal itself, buying, selling, leasing actual property. So we're able to use these digital assets as sort of a source of truth and an asset to really add transparency to those real estate deals in a variety of different ways. It could be as simple as built documentation or square footage calculations, or it could be more in depth than that. But we're also able to touch into the design and development of real estate spaces because we have such an accurate solution and a quick solution. We're able to rapidly build as-built documentation. We can also use our system for development purposes to monitor the progress of a development project, before, during, and even after a development project, to get accurate documentation of how those assets are coming together. We're also active in asset and building management. Basically, the ability to take these digital twins of buildings and use them to create as-built documentation, and then use that documentation to inform the way that we manage a building or any real estate asset, and basically use that to kind of determine what the future of that building is going to look like, how we can manage it more efficiently. It can even go into determining how we order supplies for a building, is one instance of that. We also can create virtual tours, a series of 360 images on a floor plan. These virtual tours can be easily shared with just about anybody. An instance of that would be to include them on something like a real estate listing. So these can be used for sales purposes, marketing purposes, or even building management. So it's a pretty common application of this technology, is being able to create those 360 virtual tours. So as-built documentation, that's kind of referring to two-dimensional drawings and 3D models, or BIM models. And we're able to capture these spaces and create these models or documentation kind of from scratch, using our systems, or we can use them to verify existing conditions. For buildings, for real estate, we often have some sort of plans or documentation that exist of the building, but depending on the age of the building and how well that documentation was kept, it could either be kind of piecemealed together, or it may not exist at all. So the ability to kind of start fresh and create that as-built documentation can be extremely powerful for real estate type applications. And then the ability to take these digital assets and just do square footage calculation, as well as cubic footage volume calculations, and then use that to kind of determine how you're utilizing that space, and then make decisions on how we can utilize it better, and potentially even find out how to be more profitable as well. So these are just kind of a high-level overview of some of the applications and ways that we're able to use our technology within the real estate market. As we go through this presentation, I'm going to discuss all of these in a little bit more depth. So before we do that, let's do an overview of Geoslam's products. We're going to first talk about SLAM, what SLAM is and how it relates to our products. And then we'll go through just a few of our products. The ones that particularly relate to real estate applications are the ones I'm going to focus on for this presentation. However, we have several other products both on the hardware and software side, and I would advise you to check those out if you're interested. So first, let's talk about SLAM. It's in the name of our company. It's something that gets talked about a lot more frequently within different markets. So what is it and how does it work? So SLAM is an acronym. It stands for Simultaneous Localization and Mapping. So basically what that is it's taking three-dimensional laser measurements. Those are the measurements that we're capturing with the scanner. And it is also collecting IMU positional data. IMU stands for Inertial Measurement Unit, and we're able to take that kind of simple data and use that to roughly calculate position and trajectory through an unknown space. It's not terribly accurate just by itself, so what we do is we run that data through our SLAM algorithm, and what that's doing is it's recognizing three-dimensional features. So as you're moving through a space, it will see the walls and the ceilings and the floors and all the furniture and objects around you. It will recognize those as unique features. And then as we move through the space, it will do what many refer to as a scan-to-scan registration. It's doing this continuously as we move through the space, and it's using that scan-to-scan registration to adjust our trajectory through the space and ultimately to create a registered three-dimensional point cloud. So the diagram below kind of shows what that looks like. So we initialize the scanner, its initial point, it's collecting that point cloud data and extracting surfaces. As we move through the space, it calculates our trajectory roughly with the IMU positional data, but that's prone to drift. So we run it through our SLAM algorithm and use that point cloud and the features from a second to second or instant to instant basis continuously to basically match those features together from one instant to the next. And then we use that transformation to continuously optimize our trajectory and recreate the point cloud as we move through the space. So that's kind of high level overview of how SLAM works and how we're able to create those point clouds in a mobile scenario. So the first product we'll talk about is our Zeb Revo. We also refer to this as the Revo standard. This product has been on the market for longer than any of the other products that we sell. It's really been tried and tested for a variety of different applications, and it's kind of a workhorse scanner of our product line. So just some specs on it. It's got a range of 30 meters, which is about 100 feet. It's got an IP rating of 64, which is the highest IP rating of any of our products. Just for your reference, IP rating stands for ingress protection. It's basically just rating the durability of products and their resistance to things like water and dust and those sort of things. So this one is well suited for kind of rugged outdoor or dusty or wet conditions, things like that. It really thrives in. Not terribly relevant to real estate applications, but good to note. We collect 43,000 points per second with a single laser sensor, and when we put it all together, we're able to achieve an accuracy of 1 to 3 centimeters, and that's a global accuracy. So if you were to measure from one corner of your capture to the other, that accuracy would be within 1 to 3 centimeters, which is about an inch or less accuracy, just to put that into imperial units. So with this system, all of our data and SLAM is being processed in post through our hub software. I'll talk about that in a second. We're able to integrate with a video camera to do colorization of the point cloud. We call that camera Zeb Cam, and it mounts right on the front there. There's an example of that in the bottom right picture. We're able to use the base plate on the scanner that you see the scanner sitting on to do georeferencing by using the crosshair in there to obtain reference points as we scan, and you simply do that by setting the scanner down on top of a reference point. If you hold it still for a few seconds, it will automatically log that as a reference point, and then we can use that to georeference the point cloud. We can also extract geometric objects like spherical targets or building corners and things like that to be used for georeferencing or aligning our point cloud data with this. It's got some accessories, the Zeb Cam, as we mentioned, Zeb Pano, that's a 360 camera that attaches. I'll mention that in a second in a little more detail. And then for ease of use and confined spaces, you're able to mount to a pole or a cradle to be able to access some hard to reach and hard to access areas. So the next system that we want to talk about here is the Zeb Revo RT. RT stands for real time. This system is very similar to your Revo standard. Most of the specs are pretty much the same, but the main difference between this system and the Revo standard is that we're able to do all of our data processing in SLAM in real time on the data logger. So instead of processing all of this in post after the capture, we're able to process it all as we're actually capturing on the data logger. And what this allows us to do is we can connect any mobile device, such as the phone in your pocket or a tablet or laptop or anything that's got Wi-Fi capabilities and a web browser is able to access the data logger and use a browser-based application to view your data in real time as you're collecting it. So you're able to view the data three-dimensionally and your trajectory as you walk through the space, and use that to kind of QC and track your progress as you move through the space. So because of this functionality, it's an extremely user-friendly device and one of our best sellers for real estate applications. So it's got all the same accessories as a Revo standard. So the only real notable difference in the specs of this system is that it's got a slightly lower IP rating. That's because the onboard processing on the data logger requires a little bit more ventilation than on our other systems. So the next product we want to talk about is the Zeb Horizon. The Zeb Horizon is kind of the big brother of the Revo line. It's got a longer range of 100 meters or 330 feet. It's collecting 300,000 points per second with 16 laser sensors. Overall accuracy is more or less the same as the Revo line, 1 to 3 centimeters. That's going to be universal across all of our products. So our data is going to be processed all in post in Hub. Unfortunately, we do not have a real-time system for this product just yet. That's mostly due to the increased data size. So we're able to do colorization once again with the Zeb Cam attachment, as well as georeferencing. Some important things to notice about this scanner is because we are capturing so much more point density and have such a longer range, this system actually has the strongest SLAM algorithm compared to any of our other products. So that makes it a really, really versatile product that can be used for a variety of applications. It's also very forgiving in the way that you're able to scan with it, because you're capturing features that are so far away. So I kind of refer to this as our Swiss Army knife scanner. You can use it for just about anything. Some other accessories for this scanner, because we're actually able to scan at a higher speed, we can capture data and put it together at a speed of up to 20 miles per hour. So we're actually able to mount this scanner to mobile applications at a higher speed, such as UAVs, or mount it to a car. I've seen people scan on, ATVs, golf carts, bicycles, so on and so forth. So as long as you're staying under that 20 miles per hour, you're able to put data together with this system. Another notable difference is that with this sensor, we are capturing intensity value. That's basically the material return on the data points that we're collecting, so you can actually see variations in materials. A good example of this is road lines on a road. You'd be able to see these really easily with this system, which is not the case with our Revo system. That's not capturing intensity value. So Zeb Pano, we talked about this just a little bit already, but Zeb Pano is basically integrating our scanners with a Ricoh Theta 360 camera. We can integrate with either the V or the Z model. Those have different resolutions, 14 megapixels versus 23 megapixels. These images are then processed through our Hub software, and then we can view them in our Draw software. And then we have ability to export these to a web-based HTML file as well to be easily shared with others. These images get automatically placed when you process them through the Hub software. It's basically recognizing the spot where you've taken the picture along the scanner's trajectory and marrying the picture to those spots. So they'll automatically get populated and draw in the correct place. So it's a very automated solution. So on the software side, we have Geoslam Hub. Geoslam Hub is our processing software. It's also got a point cloud viewer, so we can use that for quality control and just viewing our point clouds. We can do georeferencing here with reference points that are captured with the base plate as we've scanned. And then we can bring in a control file like a CSV file or TXT file to actually put our point clouds on a real world coordinate system. We can do colorization here using the ZebCam attachment. We can bring in those pano images like I just mentioned. We can export to our universal file formats. And then we also integrate directly with our draw software, which I'll talk about here in just a second, but there's a button for each project where you can just click on that. It'll automatically create a draw project and bring you over to that software. So we have a close integration with it. This is what Geoslam Draw looks like. In Draw, we're basically taking the point cloud and we are viewing it by way of orthographic images. So we basically taken the point cloud from a top view, a side view, and a front view, and then created orthographic images of those views. So we're not really working directly from the point cloud. We're working from a scaled image of a view of that point cloud, and we're able to create new views as well with some section tools. We have the ability to take that ortho image and automatically or semi-automatically vectorize it and turn it into CAD work. We have an integration with Revit to do scan to BIM applications. I'll show that in a minute as well. We can bring in those pano images. We can view them here. We can export those pano images to a web viewer. We can also do additional georeferencing and aligning using targets such as spherical targets or checkerboard targets, or we can manually pick points as well to do georeferencing and or alignment. We can create new layouts and sections in ortho images and then subsequently vectorize those in order to create CAD deliverables, and I'll show that process here as well. And then, of course, we can export to a variety of different formats, most notably universal file formats such as E57 and LAZ, LAS. We can also export directly to a recap RCP format, which is Autodesk's point cloud software. So we integrate really well into Autodesk software, which many people are using for BIM and CAD applications. We have a few different modules of this product. The standard package comes with our start module, but we do have modules available for different applications. We have a plan module that's got some features for drawing different 2D plans. We've got that BIM module that has the integration into Revit. We have a mining module for mining specific applications, and then we have a pro module that's got all of the features included within it. All right, so that's our product suite, at least the ones that are most closely relating to real estate applications. So let's get into some real estate applications and show you what those look like. So the first thing we're able to do with these point clouds, and we've already kind of talked about it, but this is some visual example of how we do it, is creating two-dimensional as-builts by way of floor plans, elevations, section views. Those can have a varying level of detail depending on your needs, from a simple line drawing to more of a dimensioned, construction level as-built documentation. So through our draw software, we're able to take those ortho images or vectorization of the ortho images or export the point cloud and then integrate those right into a CAD platform. So I'll show an example of how to do that within AutoCAD, but we can integrate with just about any CAD platform out there. And use that to verify existing drawings. So if we already have some base building documentation that we want to verify and make sure is accurate, we can do that, or we can start from scratch and create all new drawings. So I'll show how to create those when we get into our workflow section, specifically in AutoCAD. So the next application is three-dimensional modeling, specifically as-built models. This is commonly referred to as BIM, or Building Information Modeling. And I'll show an example of how to do this in Revit. But the process is pretty simple. Essentially, we are able to export our point cloud as a universal file format from Hub and Draw. Again, with Autodesk, we can export directly to a recap RCP format, which integrates really nicely with Autodesk software. We can bring that point cloud into our modeling BIM software, and then we can do some manual modeling just by simply using the point cloud as kind of an underlay. Or there are ways to do automated or semi-automated modeling using feature recognition and extraction tools. And we have an example of that I'll show you within our Draw software. It's called the 4CAD Revit plugin, and I'll show you what that looks like. But there also are a variety of third-party applications and plugins that are able to do feature extraction and feature recognition for scan to BIM applications that are able to add some efficiency into this process, so it's not so manual and time consuming. So I'll talk about that a little bit more as well when we get into the workflow portion. So this is just kind of a quick video animation of what that process looks like. We've got a point cloud here. I believe this is 12 different stories all put together and registered together. And then from that, we're able to use that as an underlay and build a three-dimensional BIM model off of that. I believe this example was done in Bentley MicroStation, but we're able to do this in just about any BIM platform that exists out there, especially the major ones, the commonly used ones. All right, so 360 Pano tours. These are really commonly used, especially more so nowadays that 360 camera technology is becoming more consumer grade and readily available. So 360 Pano tours, we're able to create within our Draw software by importing those Pano images from our Zeb Pano attachment. Those automatically get integrated by marrying the image to the trajectory, and then we can export those out to a web viewer. That's an example up on the top left of what the web viewer looks like. And then we can use this for a variety of different applications, including for real estate, including sales and marketing. Being able to show our space virtually. An example of how we can do this is like on a real estate listing, or virtually to actually try to sell the space, or be able to show it off without actually having to visit it in person. We can also use this for applications in asset management and building management, just to be able to document the conditions of our space and be able to manage that all virtually without actually having to visit it in person as well. So 360 image technology and 360 tours is kind of a booming tech at the moment. I hear more and more about it every day, and there's new products coming out within this realm every day. I think one of the main advantages of our system is that we're capturing that point cloud data. We're doing it in a mobile application, so it's very fast and efficient. You also have the accuracy of a point cloud, that centimeter accuracy, and then you're integrating the images with that point cloud. As opposed to some other 360 tour software that is just leveraging imagery, we really have much higher accuracy kind of paired with the 360 imagery than if you were to just use 360 imagery. Some of those tools actually do develop a three-dimensional model or a mesh that can be used, but the accuracy of our system compared to those is much better. So that's one notable difference there. We're also able to integrate these pano images into some third-party tools. There's a couple of different opportunities out there to do that, but the one I'll note here is an application called Context Capture. Context Capture is owned by Bentley Systems. Basically, in Context Capture, we can bring in our point cloud as a universal file format, and then we can create a mesh of that point cloud. And then we can also import the trajectory along with the ZebCam video that we captured and use that to colorize the mesh. And the result of this is basically like a 360 tour. And what's cool about it is it doesn't actually rely on those 360 images at all. So this is one example of how our products are able to integrate with some third-party softwares. This is kind of an example of what that looks like in Context Capture. So you can even georeference and put your mesh on like a three-dimensional satellite map, and then you can create all kinds of different views and kind of preset areas that you can jump into. You can fly through that mesh, and this is going to fly into kind of a mechanical space on a building. So an application of this is in building and asset management, where we can actually take sections of that mesh and start classifying them as specific objects, and then add metadata to those areas that we've classified, such as part and model numbers and maintenance schedules and things like that, and use those to kind of manage some of our mechanical or industrial assets within a building or in a factory setting, manufacturing, so on and so forth. We can also use this application just as kind of a virtual fly through and walkthrough for those sales and marketing applications as well. So it's a really cool tool. It's really nice just because it's basically utilizing that point cloud, so you're getting the accuracy of the point cloud, but you're not bringing in those 360 images, so you're not tied to individual spots where you've taken 360 images. You can view this asset virtually from anywhere. So it actually has some increased functionality in that way. All right, so we'll talk briefly about facilities and asset management. So there's a lot of applications for point cloud technology, as well as scan to BIM technology within the realm of facilities and asset management. I'm just going to touch on a few of those. Many of these applications, especially the ones I'm talking about now, kind of intersect with architecture, engineering, construction applications, as well as development, building and real estate development applications. But one really useful way to use our technology in the realm of facilities and asset management is above ceiling scanning. So most buildings these days have acoustic ceiling tiles, and it's really quite difficult to map or to survey assets in a ceiling plenum using traditional methods. You'll spend a lot of time with your head above the ceiling. You can also do this type of mapping with terrestrial static scanners. However, it's a much more time-consuming and kind of invasive process to do that. But with our system, it's really as simple as mounting the system to a pole, and then as you're scanning through the space, you can pop the scanner up above the ceiling, give it a quick turn to capture everything up there, pull it back down, and then continue scanning below ceiling. And you can do that as many different locations as you want throughout the capture, and you'll end up with a complete three-dimensional point cloud of your above ceiling assets. And then ultimately, if you want, you can model those in a CAD or a BIM type tool to have some as-built documentation of what's up there. So we can do this in a relatively short and easy process, as opposed to traditional survey methods, which are very invasive and time-consuming. We can also do a similar type application for for industrial purposes. I believe the example below is a baggage handling system at an airport. So we can use our technology to map and document really any kind of industrial or mechanical assets. The only real limiting factor here is going to be the size of the object, just due to our capabilities and the mobile nature of the scanning. Objects that are really small don't tend to come over very cleanly in our applications and in the actual point cloud. So that's really the only limiting factor there. We can also do kind of facilities and asset management using those Pano tours and those 360 images that we've collected as well, just as kind of visual documentation as well. So the last application I'm going to talk about here is square footage calculation, documentation, and analysis. So with the point cloud, we have this three-dimensional asset. We're able to bring that into different BIM and CAD tools and use it as an underlay to calculate square footage, and then kind of use that calculation to document how big the space is and how we're utilizing that space. So we can start classifying some of these areas by the way that they're being used and answer questions like, how much of our space are we using for storage? How much are we using for actual customer uses, whether that's office space or housing or whatever it might be. So we can kind of analyze how we're currently using the space and then use that to make decisions about how we can more efficiently and effectively use the space to help inform development into the future, or if we have a real estate asset that's changing hands, how we can better utilize the space that's already being used now. So common applications of this would be in like an office space. We can better utilize our office space to have more people in it and have it be more functional, and things like that. Ultimately, in a lot of cases, we can figure out how to make our spaces more profitable and make us more money, which at the end of the day is a lot of our goals. So. All right, so we'll go through some workflows. I'm going to show you how to create two-dimensional plans and 3D models using our software, Geoslam Hub and Geoslam Draw, and then bringing that into BIM and CAD software. In this example, I'm going to be showing Autodesk AutoCAD as well as Revit and what that workflow looks like. So I have some pre-recorded screen capture videos that I'll kind of talk through as we view them. So first we'll talk about the workflow through Hub and Draw and how to create assets that we can bring into CAD and BIM applications. So this is what that looks like. This is our Hub software. We have the ability to merge data sets together. So this is an office space that I've done 2 separate captures in. And then I'm merging these 2 data sets together. We do kind of a rough visual alignment in a top view and a side view. And once we have it put together roughly in the spot that we want it, we can direct it where to export these files to and start our merge. This will only take a couple minutes to run. Then over in our Draw software, we can create a new project. We can open up both of those files that we exported and merged together, and then we have basically a complete ortho image floor plan of our building. So most people don't want to work on a skewed coordinate system, so we're able to do a orthographic alignment by setting our origin point. That's the first click I made, and then your x-axis, which is the second point that you click. Once you've got that where you want it, you can redraw those standard views, so standard top, standard front, standard left. Again, those are default when you create the project. So once we have it on the coordinate system that we want, we can go ahead and export this out. So we just select the area that we want to export. And then we select the file type that we want to export to. Here I'm going to export to an RCP format. Hit play, and it just takes a couple minutes to export that. And again, that's exporting the actual point cloud itself based off the area you select in the ortho image. So we can create new layout views by using our layout tool. You can define the scope of those layouts, and you can do this either in a horizontal or vertical section to create building sections and elevations, as well as floor plans like the one I'm showing here. So once we have this, this section view created, we can actually do an automatic vectorization from this ortho image. So it's basically just looking at those vertical surfaces and attempting to draw lines over them. It's kind of a rough tool to kind of vectorize from a point cloud. So we can clean up those vectorization lines over in our Draw software, or we can bring them into a CAD package and clean them up there, and then use those to produce those as-built drawings or sections or floor plans. So next we'll talk about what the workflow looks like into creating 2D plans in a CAD software. Again, this is going to be in AutoCAD, but we're going to take those elements, the ortho images, the vectorization, and the point cloud that we just exported out of Draw, and bring them into AutoCAD, which is really quite simple. So we're going to start with our ortho image here. So we just bring in the ortho image. Sorry about that. Sorry about that, technical difficulties. So we bring in our ortho image, and then we can insert our vectorization as a DWG file on top of it. So that's what we're looking at here. Next, as kind of a redundant reference, I'm going to also bring in the point cloud, and you can see those all three elements line up really well. We can adjust the view of the point cloud by transparency or by the way we colorize it. We can cut sections through the point cloud to kind of view it as a floor plan view like we did over in Draw. And then once we have everything in the way we want it, we can use that to manually or semi-automatically draw our floor plan or other drawings, and then bring in the point cloud as well, or the ortho image to do quality control on it and make sure we've drawn everything correctly. So relatively easy process. Again, there are some third-party tools and plugins within AutoCAD that allow you to do some vectorization and some feature extraction. So if that's something you're interested in, I would recommend checking those out. All right, so now let's talk about the workflow into creating a 3D model or a BIM model. This is going to be into Revit, and we're going to do it using our 4CAD plugin that we have for Draw. So this is what that looks like. We start up Revit, and we start from our 4CAD template. Then we bring this into a split screen where we have Draw on one side and Revit on the other. We start up our 4CAD tool, and then we can start drawing levels. Name those levels, select the one that you want to create, use the 3D point tool over in Draw to select the spot, the elevation where you want to create those levels, and then it'll automatically create those levels at that elevation within our tool. So that's what that looks like. Once we have our levels, we can start creating a floor plan. But before we do that, let's bring in our point cloud and use that kind of as an underlay and a QC tool as well. And we can change the colorization of that point cloud to intensity value or normals or something like that to get a better view of it. So once we've got it set up the way we want, we can start drawing walls. You just use the Create Walls tool in the Revit side, and then over in the Draw side, we can start picking points. So every 2 points that we pick with our 3D Select tool will create a wall. If you look over to the right, it's actually drawing those walls in as we're picking these points through the actual ortho image. So really quick way to kind of draw walls over a point cloud. So once we've built those, we can close the room out if we have a completed room, or we can just leave it all open and then use the native Revit tools to clean up these walls and join them all together. So that would be the next step in the process, just to get your walls looking the way you want to, and make sure they're QC'd to the point cloud. We can also do the same kind of extraction with doors and windows. So for doors, we jump into a section view and draw, and then we select the family that we want to create, whether that's a double door or single door, and then we just select 2 corners as well as the position of the handle of the door, and then it'll automatically populate that into our Revit drawing using a variable Revit family. So same process for windows, pretty much. We start from a section view, and then we can just click 2 points on either corner of the window. Once we're done, it will populate that window into Revit. This is kind of more of an exterior glazing window, so it looks a little awkward in the actual section view here, but that's what we're looking at. So once we get all of our doors and windows in, we can add ceilings and floors and other BIM elements, and we have pretty much a complete model. So yeah, it's a relatively easy process to do this. It's fairly simple. Just to give you kind of a reference on time frame to do this, I personally did this project, and the capture time was, I don't know, maybe an hour or so, processing maybe another hour, and then all of the modeling was maybe 6 or 7 hours to get us to that 3-dimensional BIM kind of simplified floor plan. So we're able to kind of capture all of this and turn it into a 3D deliverable within the course of about a day's work, which is pretty impressive, and be hard pressed to find another application that's able to get you that result. All right, so let's get into some user case studies. So we're going to talk about how a couple of different companies that are customers of our products are using them for real estate applications specifically, and it's going to be pretty much what we've already discussed. So the first company we want to talk about is called Zine24. They're a European company based in the Netherlands. And simply, they're using our technology to produce digital content and create primarily 2-dimensional floor plans for the real estate market. I believe that the majority of their work is being done on residential properties. They also do kind of small to medium-sized commercial properties as well. Basically what they're doing is they've got a fleet of Zeb Revo scanners. You can see that image down on the bottom right. That's pulled right off their website. I'm not sure exactly how many they have, but quite a lot. I believe each one of their field technicians has their own scanner as part of their standard kit. With these, they're able to go into a commercial or residential building. They're able to do a really quick scan of them and get in and out very quickly, and then also create that 2D deliverable very quickly and efficiently. So what they're able to do with that, and just a couple pull quotes from a case study we did with them recently to the right, they're able to scan 5,000 houses in 5 months. So that equates to 1,000 houses in a month, which is like 50 houses a day, assuming you're not working on weekends. So 40 or 50 houses a day, which is pretty staggering numbers to be able to capture that much space. I'd be interested to calculate how much square footage that ends up being, but it's pretty impressive. But the reason they're able to do that is because they can get in and out of a residential house that's 200 square meters, which is roughly, I think, a little over 2,000 square feet. So a pretty average size house, and scan the interior of it from the time they walk in the door to the time they leave is only about 15 minutes. So, so when you start thinking about it that way, you know, travel time is going to be your biggest factor. It's going to take you longer to get between job sites than it is to actually do the work on site. So very good application of the technology, and one of our top customers as well. So we like to market them a little bit. I recommend you check out their website. They have a lot of different marketing videos and things like that about some of the other technology and applications that they do. So they're very impressive, and I'd recommend you take a look at them. The next company I'd like to highlight here is also a long-term customer of our solutions. It's Precision Property Measurements. They are based in service the United States. Their headquarters offices in California, but I believe they have technicians all over the country. So they're really one of the leading providers in the United States of commercial and residential as-built surveys, as well as-built documentation. So they're really doing kind of the same thing that Zine 24 is doing. They're using our scanners to document commercial and residential properties, and then they're rapidly creating two-dimensional as well as three-dimensional models, I believe through Autodesk applications. So very similarly to the workflow that I've already showed you. And with this, they're able to do a lot of projects and get them done in a very short amount of time. They've quoted on the website that they've done around 18,000 as-built projects since they were founded in 2002. Now, I know they haven't been a customer of ours since 2002, so not all of those were done with our technology, but they have within the last couple of years started buying our scanners, and now have a fleet of both the Revo scanners and the Zeb Horizon scanners, and they're using those extensively in their workflows to produce this as-built documentation. So their owner, Greg Davies, has said by bringing in these tools, they're able to maintain the same accuracy that they've always been able to maintain with traditional surveying methods, you know, using distometers and things like that. But they've cut their scan time, you know, or their capture time, you know, by 10, and really increased their efficiency, and allowed them to just take on a lot more work than they normally would be able to using traditional methods. So those are two examples of companies that are doing some great things with our technology and kind of using it in a very simple and smart, intelligent way to add efficiency to their business and use that to drive more value. And they're both primarily serving the real estate market. So there's also several other companies that have this technology in-house and are using it to document their own assets. So you know, large property management groups and things like that will use this internally as opposed to hiring it out. So definitely recommend you to check out both of these companies and reach out to them if you're in need of any kind of services such as as-built documentation. All right, so that's all we have for our presentation content. So we'll go ahead and move on to Q&A and just kind of answer a couple questions that might have come up. While we do that, I'm going to go ahead and play this animation. This is actually a project that came over from Precision Property Measurements, and they let us include it in the presentation, so you can take a look as we're answering some of these questions. All right, so yeah, first question we have here is, what are some of the limitations of mobile scanning in comparison to static scanning? It's a good question. So mobile scanning has some trade-offs compared to a static scanner, which for references is a tripod-based scanner that scans in place, and then you move that throughout the building or whatever area you're trying to capture, and scan in several different locations, and then you stitch that all together on the back end. So really the trade-off here is a couple things. The trade-off is accuracy, point density. So those static scanners, because they're not moving, they're able to capture a lot more dense data in small space. And then we're also able, or then we also have a little bit more of a noisy solution. So it's going to have a bit more noise in the data compared to a static scanner. So some of those smaller elements, like small pipes or small architectural elements, are going to be kind of hard to pick up. But the trade-off really with that is with our systems, we were able to be much faster and much more efficient on our capture time, as well as on the back end. The registration and the processing time is pretty quick. And overall, I would say it's a generally an easier product to use and get into. All right, so next question that we have here is, let's see, what is the most common use of this technology? So probably the most common way that this technology is used is for some sort of as-built documentation or as-built verification. There's also, applications such as progress monitoring or just monitoring in general. That's something that's used a bit in like mining industry and things like that. But yeah, probably the most commonly used scenario is just to create, as-built two-dimensional or three-dimensional assets, just like we've talked about in this presentation. All right, so that's all the questions that I've got. I'm going to go ahead and sign off here. Again, just in closing, we do have a recording of this will be sent out to all attendees. If we have any follow-up questions, you can send those to info@geoslam.com and we'll address those, especially if you're watching a recording of this. Please visit our website for more info. Feel free to reach out to us if you're interested in a demo. Check out that demo in a box solution. So yeah, that's all I have. I appreciate everybody attending. And on behalf of everyone at Geoslam, we'd like to thank you very much for joining us. All right, goodbye and enjoy the rest of your day. Thank you.